At a young age, I discovered I had a passion for engineering, understanding that everything from how cars drive to birds fly relies on their own complete unique engineering aspects. I realized that biomedical engineering is a career that helps people improve their condition of living and further scientific advancements. Growing up in the midst of a technological boom and watching how quick, subtle changes in the engineering community resulted in massive innovation, my resources to explore the field were endless. My interest only grew as I attended school. I had been placed in advanced math and science courses and began to apply what I was learning. By age 9, I crafted my first robotic arm, a basic syringe hydraulic system. The arm could move up, down, and I kept adding to it until it could pick up a pencil. As I progressed in creation, I thought about its application. Where does mechanics and engineering have the most potential for growth, and how can I apply this to help people? Through these questions, I discovered biomedical engineering. It combined my passion of invention with my desire to help people. However, most people are unfamiliar with the profession and are informed in current prosthetic procedures. Every day, people around the world suffer accidents that result in loss of function in limbs, horrible condition, or amputation that is debilitative and changes how they live on a day-to-day basis. As stated in an article written by the University of California, Riverside, biomedical engineers build devices that can improve the lives of patients who have some form of disability or illness, where certain functions are almost lost entirely. Decades of technological advancements, while furthering the ability of prostheses, have not changed the fact that biomedical engineers must spend countless hours researching and calibrating each prosthetic in order to make them unique to its user. Each tendon in the arm must be mapped and graphed and then inlaid onto the receiving end of the prosthetic. This allows the user to move the prosthetic as if it were their own hand. Through these adjustments, functionality can be restored and people's lives can be changed for the better. As technology continues to develop, biomedical engineers are continuously given new methods to increase efficiency. Recent advancements have allowed engineers to begin the process of bioprinting, which is the new systematic layering of living tissue to form a new working organ. Many people are unable to find a donor for an organ transplant because they cannot find a match with someone with comparable autoimmune systems and body types. Because the bioprinted organ would be custom tailored to the recipient, bioprinting may eliminate, dramatically reduce, or realistically reinvent the problem of biocompatibility, says the U.S. National Library of Medicine. In the future, prostheses may be able to relay the feeling of touch as well. While we are far from it now, engineers are working on how to replicate nerve synapses and wire them into the user. In theory, according to Sekel BR, engineers would be able to artificially manipulate the biological processes of nerve regeneration, allowing them to repair any nerves on the patient and fuse them with the nerves of the prosthesis. This would allow the recipient of the arm to feel the sensations from a prosthetic hand. In conclusion, biomedical engineering is now a promising career field and will continue to grow exponentially alongside technological advancements. As these advancements progress, people's lives will continue to improve, and the future of medicine will continue to be altered. Although biomedical engineering is not a well-known profession, it is an extremely influential field and should be held in high regard.